tangent line. Now, what is the meaning of a horizontal tangent line? What is its significance? What is the slope of a horizontal line? The slope of a horizontal line is 0. That means at a point where the tangent line is horizontal, the slope of the tangent line is 0, and the slope of the tangent line at a point is called the derivative. That means wherever a tangent line is horizontal, at that point the derivative of the function is 0. Is that right? Now, let's do a problem. Determine the points, if any, at which the function y equal to square root 3x. Now, don't read it as square root 3x. Square root 3 times x plus cos x has horizontal tangent line. So what is the significance of a point where you have a horizontal tangent line? At a point where you have a horizontal tangent line, the derivative is 0. Why? Because derivative at a point is a measure of the slope of the tangent line at that point. So if the tangent line is horizontal, its slope is 0. That means the derivative at that point is 0. So a horizontal tangent line has its slope 0. That means at a point where the tangent is horizontal, the derivative will be 0. So we will start by picking our function y equal to square root 3x plus 2 cos x and find the derivative of this. Alright, what is dy by dx? Dy by dx is the derivative of this term. Remember, this term is not square root 3x, but square root 3 times x. It's like 2x, 5x, and so on. So what is the derivative of square root 3 times x? The square root 3. And what is the derivative of 2 cos x? If you leave the 2 alone and find the derivative of cos x, the derivative of cos x is negative sin x. The derivative of 2 cos x is negative 2 sin x. So, if y equal to square root 3x plus 2 cos x, the derivative of that with respect to x, or dy by dx, is square root 3 minus 2 sin x. Now we want to find points where you have the horizontal tangent line. We want to find the points where the derivative is 0. At a point where you see a horizontal line, the derivative is 0. So we will set the derivative equal to 0 and solve for x. Okay, I hope you know how to solve a trigonometric function. That's the reason why we do a trigonometry course before coming to calculus. Alright, so we set the derivative to 0 and solve for x. That means square root 3 minus 2 sin x equal to 0. And this will give solve for sin x here. Can you solve for sin x? Sin x will be square root 3 over 2. That's right. Sin x is square root 3 over 2. Alright. If you know your trigonometric values, now look at this. Sine of 0 is 0. Sine of 30 degrees is 1/2. Sine of 45 degrees is square root 2 over 2. Sine of 60 degrees is square root 3 over 2. Sine of 90 degrees is 1. Now that I was talking the input x in degrees. But in equations like this, your x must be in radians. You cannot use degrees. So let's think in degrees now, knowing that 30 degrees is in terms of pi. How much is that? Is pi by 6, isn't it? 30 degrees is 1/6 of pi, 180 degrees. So 30 degrees is pi by 6. 45 degrees is pi by 4. 60 degrees is pi by 3. So, once again, sine of 0 is 0. Sine of pi by 6 is 1/2. Sine of pi by 4 is root 2 over 2. Sine of pi by 3 is root 3 over 2. Sine of pi by 3 is root 3 over 2. So what is this x? X is arc sine root 3 over 2. And that x is therefore pi by 6 in the first quadrant. Now you must know that sine is positive in the first quadrant as well as in the second quadrant. Now those understandings are very important. Alright, let's talk about this. In the first quadrant, this is pi by 3. And in the second quadrant, you can see the angle will be 2 pi by 3 because pi by 3 is the reference angle. So in the second quadrant, this is pi. Pi minus pi by 3 is 2 pi by 3. Let me explain that one more time because most of you are not very good at this, I know. So this angle is pi by 3 in the first quadrant. Now, that means the reference angle is pi by 3. So what is the corresponding angle in the second quadrant? This reference angle is pi by 3. That means you take away pi by 3 from pi, you get 2 pi by 3. That means if sine x equal to root 3 over 2, sine x equal to root 3 over 2, it will give you two values for x. Because sine is positive in the first quadrant and also in the second quadrant. Now in the first quadrant x will be pi by 3. Then in the second quadrant the value of x will be 2 pi by 3. Because try your calculator. Sine of pi by 3 is root 3 over 2. Sine of 2 pi by 3 is also root 3 over 2. 60 degrees. 120 degrees. All right. So you have x equal to arc sine root 3 over 2 will give you x equal to pi by 3 in the first quadrant and x equal to 2 pi by 3 in the second quadrant. Those information is very important. So we will take one at a time. When x equal to pi by 3, this is your position function of the moving particle. So when x equal to pi by 3, then what is y? Y equal to square root 3 times pi by 3 plus 2 cos pi by 3. And if you put this in your calculator, you will get 2.8. So when x equal to pi by 3, y equal to 2.8. That means at this point, at x equal to pi by 3, y equal to 2.8, you will have a horizontal tangent line. At that point, the derivative is 0. Similarly, when x equal to 2 pi by 3, replace x by 2 pi by 3 in this function. You get y equal to root 3 times 2 pi by 3 plus cos of 2 pi by 3, and that will give you 2.6. That means the point x equal to 2 pi by 3, y equal to 2.6. Again, the derivative will be 0. You get a horizontal tangent line. There are 2 points on the graph of this function where you get a horizontal tangent line. Now look at the graph of this function. This is the graph of y equal to square root 3x plus 2 cos x. And points of horizontal tangency are pi by 3, 2.8. Now, this is the point of 2 pi by 3, 2.6. X equal to 2 pi by 3, y equal to 2.6. That is 1 point of horizontal tangency. And this is the other point, x equal to pi by 3, y equal to 2.8. You got 2 points of horizontal tangency. Very important type of problems. You must practice this as we go on. Now, we